Hello everyone, my name is Deepa Bajetha and I am working as an Associate Professor, IIMT College of Pharmacy, Greater Noida. Today I am going to discuss about the topic heterocyclic compound, in which I will explain pyrrole. So what is heterocyclic chemistry? Heterocyclic chemistry is branch of organic chemistry dealing with the synthesis, properties and application of these heterocycles. So what is heterocyclic compounds? Heterocyclic compounds are the compounds that contain at least one or more than one heteroatom in the elements. Or we can say that heterocyclic compounds are the organic compounds that contain rings composed of carbon and other atoms. In natural, heterocyclic mostly nitrogen, sulfur, and oxygen. These common heteroatoms are also called non-carbon atoms. Number of drugs in the pharmaceutical science are the heterocyclic compounds. Heterocyclic compounds synthetically or naturally available in the market. So next is classification of heterocyclic compounds. How we can classify these heterocyclic compounds? So heterocyclic compounds are classified into different categories. First one is 5-membered heterocyclic compounds. Second one is 6-membered heterocyclic compounds. And third one is 7-membered heterocyclic compound. And fourth one is condensed heterocyclic compounds. So first category, in which 5-member heterocyclic compound, is further divided into two categories, in which first is heterocyclic compounds having one heteroatom in the ring, and there are some examples. First is furon, pyrrole, and thiophene. Another one is heterocyclic compounds having more than one heteroatoms. Examples are pyrazole, imidazole, oxazole, isoxazole, and thiazole. And in 6-member heterocyclic compounds are further divided into two categories, same as in 5-membered heterocyclic compounds having one heteroatom. Examples pyridine and piperidine, and heterocyclic compounds having more than one heteroatoms. Examples pyrimidine, pyridazine, and pyrazine. And 7-member heterocyclic compounds, there are some examples like oxazepine and 1-hydroazepine. And condensed heterocyclic compounds are the compounds in which heterocyclic rings that are fused together with other rings, either carbocyclic or heterocyclics. In which there are some few examples like indole, quinoline, isoquinoline, and purine. So first category, in which 5-member heterocyclic compounds having one heteroatom. As you can see in the structures, first category, in which first example is furan, and furan, oxygen having oxygen as a heteroatom in the 5-member ring, and in pyrrole, nitrogen as a heteroatom, and in thiophene, sulfur as a heteroatom. Next is 5-membered heterocyclic compounds having more than one heteroatom. There are some examples. First is pyrazole. Here in first and second position, you can see two nitrogen heteroatom in the ring, and imidazole in first, second, and third position. First and third position, nitrogen as a heteroatom in the imidazole, and in oxazole, oxygen and nitrogen is a heteroatom in the ring, and in isoxazole, oxygen and nitrogen as a heteroatom in the ring, and in thiazole, sulfur and nitrogen as a heteroatom in the cyclic ring. So 6-member heterocyclic compounds having one heteroatom. There are some examples. These are the 6-member heterocyclic compounds in which one nitrogen or one heteroatom as a present in the ring. In pyridine, nitrogen as a heteroatom in the ring, and in piperidine, nitrogen and hydrogen with the ring. Next category is six-member heterocyclic compounds having two heteroatom present in the ring. For example, pyrimidine, pyridine, and pyrazine. There are some examples in which two heteroatom present in six-membered ring. There are some few examples in seven-member heterocyclic compounds, oxypine and one hydroazepine. This ring is seven-member heterocyclic compounds. And last one is condensed heterocyclic compounds, in which examples are indole. Indole is bicyclic structure consisting of six-membered benzene ring fused to a five-membered pyrrole ring. Next is quinoline. Quinoline is the simplest member of the quinoline class of compounds, comprising a benzene ring orthofused to carbon second and carbon third of a pyridine ring. Next one is isoquinoline. Isoquinoline orthofused heteroarene, that is benzopyridine, in which the nitrogen atom not directly attached to the benzene ring. And purine heterocyclic aromatic organic compound that consists of two rings. First one is, you can see here, first one is pyrimidine, which is six-membered hydrogen ring, and second one is imidazole, that is five-membered, fused together. Examples of alkaloids, number of heterocyclic compounds. So next is introduction to pyrrole. What is pyrrole? Pyrrole is an important five-member heterocyclic compound possessing a nitrogen atom as a heteroatom. It plays important role in the chemistry of living organism. The essential structure feature of chlorophyll and heme is porphyrin, which consists of four pyrrole rings held together by brace. Pyrrole rings are present in number of natural products, for example, alkaloids, hemoglobins, synthetic pharmaceuticals, chlorophyll. This is porphyrin ring. You can see in the structure, this is porphyrin ring where four pyrrole rings are fused together. And in chlorophyll, the four pyrrole rings are fused together with Mg, and in hemoglobin, four pyrrole rings are fused with Fe iron. Next is properties of pyrrole. Pyrrole having molecular formula C₄H₄N, and IUPAC name of pyrrole is 1 hydrogen pyrrole. It is colorless liquid. It is sparingly soluble in water, means it is slightly soluble in water but easily soluble in organic solvents like ethanol and ether. Pyrrole boils at 129 to 131 degree Celsius. It is amphoteric in nature, means having two natures. It is weak base as well as it is weak acid. Next is structure of pyrrole. In structure of pyrrole, pyrrole has three pairs of delocalized pi-electrons. So what is delocalized pi-electrons? Delocalized pi-electrons is an electron in an atom, ion or molecule that is not connected to a single atom or covalent bond. So these delocalized electrons in a ring structure are represented by a circle rather than a single and double bonds. It means that electron cloud could be anywhere along with the chemical bond. So these three pairs, in which two of the pairs are shown as bond and third pair is shown as pair of non-bonding electron on the heteroatom nitrogen. This nitrogen as a heteroatom. Here one pair of non-bonding electron is present. Four carbons and nitrogen atom both are sp2 hybridized. In this structure, these four carbon atoms or these nitrogen atoms both are sp2 hybridized. Since it is cyclic, it is planar molecule with the three pairs of delocalized electrons fulfill the criteria for aromaticity. Any compound should call cyclic or aromatic if any heterocyclic compound fulfill the criteria of aromaticity. There are some parameters in which first is cyclic, it should be planar or it should have three pair of delocalized electrons. Planar molecules, the molecules when all of its atoms lies in the same plane. What is aromaticity of pyrrole? For any organic compound to be aromatic, they have followed three criteria. First criteria is it should have cyclic. Cyclic means it should all atoms lie in the same plane. And planar structure and cyclic, it should have delocalized pi-electrons. It should obey Huckel's rules 4n plus 2 pi electrons. Here value of n is 0, 1, 2, 3, 4. Any heterocyclic compounds obey Huckel's rules. Therefore, it is an aromatic compound. Pyrrole obeys all the parameters of Huckel rules, so it is an aromatic compound. Next is preparation and synthesis of pyrrole. How we can prepare and synthesize pyrrole in the laboratory. So first is pyrrole is obtained commercially by the distillation of coal tar and it is synthesized in the laboratory by the following different methods. Pyrrole occurs in coal tar and in bone oil obtained from dry distillation or pyrolysis of animal byproducts such as horns, hoofs, and bones. So next is acrylic test in which pyrrole plus p-dimethyl aminobenzyl aldehyde gives intense red color. So next method is we prepare or obtain pyrrole from furan method. So first is from furan. When we furan on heating with ammonia in the presence of alumina Al2O3, it gives pyrrole. Second method is from the distillation of succinimide. Pyrrole is obtained by the distillation of succinimide with zinc dust. Succinimide gives pyrrole in the presence of zinc dust, it gives zinc oxide. Next is chemical properties. In chemical properties, first is reduction reaction, oxidation reaction, ring expansion reaction, ring opening reaction, electrophilic, aromatic substitution reaction, nitration, sulfonation, chlorination, iodination, and acetylation. So first is reduction reaction. In reduction reaction, pyrrole on reduction with zinc and acetic acid gives 2,5-dihydropyrrole, which on reduction with hydrogen iodide and gives red phosphorus, gives pyridine. When we treat pyrrole in the presence of zinc and acetic acid, it gives 2,5-dihydropyrrole, which on further treat with hydrogen iodide and phosphorus, red phosphorus in the presence, it gives pyrrolidine. And second is oxidation reaction. In oxidation reaction, pyrrole is oxidized to melanimide, that is imide of acetic acid, with chromium trioxide in acetic acid. When we treat this pyrrole with nascent oxygen atom, nascent oxygen, it has high tendency to react with the other nascent oxygen and to obtain the oxygen O2 molecules. So if pyrrole is treated with the nascent oxygen atom in the presence of chromium trioxide and acetic acid, it gives melanimide, that is imide of acetic acid. Next is ring opening reaction. Ring opening reaction, a reaction in which one polymer chain has reactive center on its terminal and that reacts with another cyclic monomer, hence its ring system to form a longer polymer chain. Pyrrole ring structures opens and forms succinyaldehyde dioxime, that is addition product on reflection with ethanolic hydroxylamine. So in this reaction, when we treat this pyrrole with succinyaldehyde dioxime and reflux, so it gives succinyaldehyde dioxime with the presence of ethanolic hydroxylamine. Second is ring expansion reaction. Ring expansion reaction which can lead to the expansion or contraction of an existing ring. So in this, pyrrole ring expands on heating with potassium pyrrole with chloroform and sodium ethoxide. So this potassium pyrrole gives 3-chloropyridine with the treatment of chloroform and sodium ethoxide. Next is electrophilic aromatic substitution reaction. Electrophilic aromatic substitution reaction means the substitution of one electrophile by a stronger electrophile. The main definition of electrophilic aromatic substitution is means substitution of one electrophile by a stronger electrophile. When electrophilic substitution takes place at second position of pyrrole, it will lead to the formation of three resonating structure. If pyrrole undergoes aromatic substitution at carbon second position, so it gives three resonating structure. If electro substitution takes place at third position of pyrrole, it will lead to the formation of two resonating structure. More resonating structure, more will be the stable compound. Thus, when pyrrole undergoes electrophilic aromatic substitution, substitution occurs at the second position of the pyrrole. Generally, electrophilic substitution takes place at second position of pyrrole, but when the second position is occupied by any electrophile like halides or any stronger electrophiles, then substitution occurs at third position. When there is more charge distribution, more will be the resonating structure, more will be the stability of the compound. Pyrrole undergoes electrophilic aromatic substitution more rarely at carbon 2 and carbon third position. Mechanism of electrophile aromatic substitution of pyrrole involves following steps. There is number of steps involved in this. First one is generation of electrophile. Second is attachment of electrophile to the aromatic ring to form intermediate carbocation. And third one is elimination of proton from carbocation to form substitution product. So in first steps, we generate an electrophile. And in second step, these electrophile attach with the pyrrole to form an intermediate carbocation. And in step third, these intermediate carbocation gives substitution product with proton. Here, elimination of proton from carbocation to form a substitution product. In pyrrole, electrophilic substitution takes place at second or fifth position. If these positions are filled, substitution takes place at third or fourth position. The intermediate resulting from carbon second substitution has three resonating contributors. The intermediate resulting from carbon third substitution has only two resonance contributors and has positive charge on a primary carbon which is unstable. The substitution at carbon 2 is predominant. Next is nitration, sulfonation, chlorination and iodination reaction with pyrrole. When we treat pyrrole with HNO3 and acetic anhydride, it gives 2 nitropyrrole. At second position, nitro group is attached. And in sulfonation, when we treat pyrrole with sulfur trioxide and in the presence of pyridine at 100 degrees Celsius, it gives 2 pyrrole sulfonic acid. Next is in chlorination reaction, when we treat pyrrole with sulfuryl chloride, it gives 2, 3, 4, 5 tetrachloropyrrole. At second, third, fourth and fifth position, chlorine will be attached. And in iodination reaction, pyrrole is treated with iodine. In the presence of aqueous potassium iodide, it gives 2, 3, 4, 5 tetraiodopyrrole. And in acetylation reaction, it gives 2-acetyl-pyrrole when we treat pyrrole with tin tetrachloride in the presence of acetic anhydride at 200 degree Celsius. So these are the reactions: electrophilic, aromatic substitution reaction, or chemical properties of pyrrole. So last one is medicinal uses and compounds. Chemically, procyclidine is alpha cyclohexyl and alpha phenyl 1 pyridine propanol. It is an antimuscarinic drug used in the treatment of Parkinson disease. Next important use is proline, a major amino acid found in cartilage, and it is important for the maintaining youthful skin as well as repair of muscle, connective tissue and skin damage. An essential component of collagen and is important for proper functioning of joints and tendons. Next is nicotine. Nicotine is also used as a medicinal compound in which pyrrole is as a ring compound, and it is a stimulant and potent parasympathetic alkaloid. It is used for smoking cessation to relieve withdrawal symptoms. And third one is procyclidine. Procyclidine is anti-chlorinic drug, cholinergic drug used to treat the stiffness, tremors and involuntary movements and poor muscle control of Parkinson disease. And there are some other few examples like glycopyrrolate. It is an anticholinergic drug which is used in a peptic ulcer. And Atorvastatin belongs to a group of drugs known as statins used to reduce high cholesterol level in the blood and also reduce the risk of heart attack and stroke. So there are few examples of the medicinal compound, heterocyclic compound, in which pyrrole as a cyclic ring, in which pyrrole as a cyclic ring present in the structures. Thank you.